In this video, I want to talk about what is a tangent line and how we can find the equation of tangent line using derivatives. What is a tangent line, or simply tangent? To answer this question, consider this curve with a point like P with the coordinates x sub 0 and y sub 0 on the curve. The word tangent is derived from the Latin word tangens, which means touching. So, a tangent line to a curve at a given point is the straight line that just touches the curve at that point. For example, in this figure, consider the three lines A, B, and C that have passed through point P. Only one of these lines is tangent to our curve at the point P, and other lines are not tangent to our curve. Actually, lines B and C are not tangent to our curve. They have crossed our curve at the point P. Only the line A just touches at one point our curve. So this line is tangent to our curve at the point P, and other lines are not tangent to our curve. But what is the difference between line A and line B and C? What makes line A tangent but lines B and C are not tangent? The difference between line A and line B and C is the slope of line A. The slope of the line A equals the slope of our curve at the point P, but the slope of lines B and C is not equal to the slope of our curve at the point P. Now we get to our next question: how we can find the equation of the tangent line for a function at a point. Fortunately, you can use the following 4 steps in most of the questions to find the equation of tangent line. The first step is to take derivative of your function. The second step is to evaluate derivative of your function at the given point. The third step is to find the y-coordinate of the point. In some questions, you are not given the y-coordinate of the point P. In those kind of questions, you have to plug in x sub 0 in your function to evaluate the y sub 0, the corresponding y of the point P. And finally, the last step is to use the point slope formula to write the equation of the tangent line. Now let's try an example. Find the equation of tangent line to the curve f of x equals x squared plus x at the point 1, 2. Before I solve this example, let's review the steps for finding the equation of tangent line. The first step is to take derivative of the given function. The second step is to evaluate derivative at the given point. The given point in this example is 1 and 2. After we take derivative of the function, we have to plug in x coordinate and sometimes x and y coordinate in the derivative. Find the y coordinate of the given point. In this example, the y coordinate is given, so we don't need to find the y coordinate. Anyway, the next step is to use point slope formula to write the equation of tangent line. Let's start. The first step is to take derivative of the given function. The given function is x squared plus x, and we have to find derivative of this simple function. Derivative of x squared according to power rule is 2x, and derivative of x is 1. After we take derivative of the function, we have to evaluate derivative of the function at the given point. So we have to substitute 1 for x in the derivative to find the slope of the curve at this special point. If we substitute 1 for x, f prime of 1 equals 2 times 1 plus 1. 2 times 1 is 2 plus 1 is 3. 3 is the slope of the tangent line. Usually we show the slope of tangent line, slope of any line, with the m notation. So a slope of tangent line is 3. Let's review it again. First we take derivative of the given function. After we take derivative, we have to plug in the given point, the x and sometimes y coordinate of the given point in the derivative. In this example, we plug in 1 for x to find the slope of this curve at this special point. If we plug in 1 for x, 2 times 1 is 2 plus 1 is 3. And 3 is the slope of the tangent line. The next step is to find y-coordinate of the point. In this example, you are given the y-coordinate of the point, so you don't need to find the y-coordinate. So we skip this step in this example and we jump to the next step. Now using the point slope formula of equation of a line, we can write the equation of tangent line. Let me remind you the point slope formula of a line. Y minus y sub 1 equals m times x minus x sub 1. X sub 1 and y sub 1 are the x and y coordinate of the point, and m is the slope of the line. In this question, x sub 1 is 1. Y sub 1 is 2. Then the slope of tangent line is 3. So x sub 1 is 1, and y sub 1 is 2, and the slope of tangent line is 3. If we plug in these values in the point slope formula, we have y minus 2 equals 3 times x minus 1. So this is the equation of the tangent line to this curve at this point. This answer is completely correct and you don't need to do anything else. But usually we prefer to write the equation of the tangent line in the slope-intercept form. Or in another word, we want to solve this equation for y. If we distribute 3 in these curly brackets, we have y minus 2 equals 3x. 3 times x is 3x. 3 times negative 1 is negative 3. And now if we add 2 to the both sides of this equation, y is 3x minus 1. Note that negative 3 plus 2 is negative 1. And this is the simplified form of tangent line. Before I finish this example, let me show you the graph of this function and its tangent line. This curve is x squared plus x, and this line which touches our curve at the point 1 and 2, note that this point that the line touches our curve is 1 and 2. X is 1 and y is 2. And the slope of this line is 3. This line is y equals 3x minus 1, which is our tangent line. And as you can see, it just touches our curve at only one point, and that point is 1 and 2. Let's try another example. We are asked to find the equation of the tangent line to the graph of f of x equals x plus cosine x at the point x equals 0. The first step for finding the equation of tangent line is to take derivative of the given function. We have to find derivative of x plus cosine x. Derivative of x is 1 and derivative of cosine of x is negative sine of x. So derivative of x plus cosine x is 1 minus sine x. Now we have to find derivative of the function at the given point. The given point is x equals 0. We have to substitute 0 for x in derivative. If we plug in 0 for x in derivative of the function, we have f prime of 0 equals 1 minus sine of 0. We know that sine of 0 is 0. So f prime of 0 equals 1. 1 minus 0 is 1. 1 is the slope of the tangent line at x equals 0. The next step is to find the y-coordinate of the given point. We want to find the equation of the tangent line at x equals 0. Because in this question, we don't have the y-coordinate corresponding to this point, we have to plug in 0 for x in the function to find the y value. If we plug in 0 for x in the function, we have 0 plus cosine of 0. Cosine of 0 is 1. 1 plus 0 is 1. So the y-coordinate of the given point is 1. And so the coordinate of the point is 0, 1. Now that we have the slope of the tangent line and the x and y coordinate of the point, easily we can use point slope formula to write the equation of tangent line. The point slope formula is y minus y1 equals m times x minus x1. x1 is 0, y1 is 1, and the slope of the tangent line is 1. So the equation of the tangent line is y minus 1 equals 1 times x minus 0. And this is the equation of the tangent line to this curve at this point. You can leave the equation in this form, or you can simplify it and solve it for y. To solve this equation for y, first I multiply 1 in this bracket. 1 times x is x, 1 times 0 is 0, so y minus 1 is x. Now if we add 1 to the both sides of this equation, we can write the equation of the tangent line in the following form. Y equals x plus 1. We move the negative 1 to the other side of the equation and we get to this form. This is the equation of the tangent line in the simplified form for this function at this point. Let me show you the graph of this function and its tangent line at this point. This curve here is x plus cosine x, and this is the tangent line to this curve at the point 0 and 1. Let's try another example. We are asked to find the equation of the tangent line to the graph of f of x equals x sine x at x equals pi over 2. The first step is to find the derivative of the function. Our function is x sine x, and to find the derivative of this function we have to use product rule. Note that we have two terms, x and sine of x. We have the product of two terms, so we have to use product rule. Let me remind you product rule. The derivative of f times g, product of two functions, is write the first function, f is the first function, write the first function times the derivative of second function plus second function times the derivative of first function. According to the product rule, the derivative of x sine x is x, we write this first function, we multiply it by derivative of the second function. Derivative of sine of x is cosine of x, plus write the second function is sine of x, times derivative of the first function. Derivative of first function, derivative of x is 1. So derivative of x sine of x is x cosine of x plus sine of x. We can ignore 1. 1 times sine of x is sine of x. So derivative of x sine of x is this expression. After we find the derivative of the given function, we have to evaluate this derivative at this point. We have to plug in pi over 2 for x. If we plug in pi over 2 for x, we have f prime of pi over 2 is pi over 2 cosine of pi over 2 plus sine of pi over 2. Cosine of pi over 2 is 0 and sine of pi over 2 is 1. So this term is 1, cosine of pi over 2 is 0, 0 times pi over 2 is 0, so the first term is completely 0. 0 plus 1 is 1. 1 is the slope of the tangent line. Let's review it again. Sine of pi over 2 is 1, cosine of pi over 2 is 0, 0 times pi over 2 is 0, 0 plus 1 is 1, and 1 is the slope of tangent line. After we completed this step 2, we have to go to the next step. We have to find the y coordinate of the point. Because we are not given the y coordinate of the point, we have to plug in pi over 2 in the function to find the corresponding y to this x. If we plug in pi over 2 in the given function, we have pi over 2 times sine of pi over 2. Sine of pi over 2 is 1. 1 times pi over 2 is pi over 2. So the y coordinate of the point is pi over 2. And so the coordinates of our point is pi over 2, comma pi over 2. X is pi over 2. Also, y is pi over 2. Now that we have the slope of the tangent line, and we have x and y values of the point on the function, we can use point slope formula to write the equation of tangent line. This is the point slope formula of a line. Y minus y1 equals m times x minus x1. M is the slope, x1 and y1 are the x and y coordinate of the point. If we plug in these values in this equation, we have y minus pi over 2 equals, the slope is 1, times x minus pi over 2. And this is the equation of the tangent line to this curve at this point. And you can leave the equation in this form. But usually we prefer to isolate y, or in another word, we prefer to write the equation in the slope-intercept form. If I multiply 1 in this curly bracket, nothing changes. So I can write this answer in the form of y minus pi over 2 equals x minus pi over 2. And now if we add pi over 2 to the both sides of this equation, we can get rid of these two terms. And finally we have y equals x. This is the simplified form of the equation of tangent line to this function at this point.